Hello, everyone. My name is Thomas Bertani. I'm the founder of Oracleize. So when we started trying to solve the Oracle problem in 2014, 2015, like the entire ecosystem was still in its infancy. And we had to waste like pretty much 50% of our speaking time at presentations just to introduce the Oracle problem. Today in this event, we have, I think, 4 or 5 presentations on the Oracle's problem. And there are different teams, such as Witnet, Chainlink, and many others, that are trying to address the Oracle problem. So we don't have to dedicate 50% of the time just to explain why oracles are important and why data-rich smart contracts are really needed to move the space forward. So I'm really happy today to be able to use just slide 0, like the a small corner of the slide, like the bottom of the slide, basically, to like briefly introduce the Oracle problem for those who are seeing like this for the first time. So basically, long story short, in 10 seconds, the Oracle is like an entity which enables you to get data that you need within the blockchain context. So the blockchain is by itself like a walled garden, so it's not possible to reach out to any external data, and this makes it impossible for smart contracts to depend on external real-world conditions. So it's really important to have this infrastructure piece in place, and as we have seen in the previous presentation, I mean, the end user shouldn't really care about what technology is being used under the hood. What the end user cares about is the application being easy, simple, secure, and just working. So this is basically a technical piece of infrastructure that we need for blockchain to go to the masses and have some kind of implications on the real world. So Oracleize has been solving this problem for a few years. We have started in 2014, kicking off the project on Bitcoin, actually. We moved to Ethereum after the mainnet launch, which happened in, I think, August 2015, if I'm not wrong. And at DevCon 1, we announced the service in London in 2015. And since then, well, basically, we got traction on the Ethereum mainnet if you consider the smart contracts trend something where traction fits as a term, in the sense that, as you know, we are building many pieces of the infrastructure, and they are getting adopted slowly. So what are the main use cases that we see in the space? We know decentralized finance could be huge. We know that there are many other potential implications for insurance, banking, and much more. So what we try to do here on the side, on the right part of the slide, is basically looking at the Oracleize-based projects, which at the moment are approximately 1,000 on GitHub. And we try to look at their scope, like their industry, basically, the reference market they had. And this is too small for you to read the text, but I will help. So basically, the big chunk, the big slice of the pie in blue is, guess what? Gambling. So gambling is definitely one of the use cases on blockchain which is getting more traction. We have seen also on Bitcoin itself, the first spike in number of transactions happening in 2012 was because of Satoshi Dice, like a gambling platform. And since then, gambling, also on Ethereum has become more and more important. There are many gambling applications. So why would a gambling project reach out to an Oracle? Well, basically because getting on-chain randomness is kind of complicated, and there are always some risks to be considered with mining potentially being able to collude, or many other problems. Now this presentation is not on randomness, but you can do your homework and find out that basically it's quite complex. And while there are many projects trying to solve the randomness problem on chain, at the moment it's not really ready to be used by casinos or by gambling applications today. Maybe in a few years the landscape will be different, but this is the case today. So they are reaching out to an external context and asking for randomness to be generated typically within a trusted execution environment or some kind of provably safe context, basically, but different from the blockchain. Another big use case is the yellow one. Sorry, the green one is ICOs, and the orange one is assets and tokens. So these are basically tokens or projects that had to get some price feeds or some reference data from the internet or from some data sources. For instance, there are some asset-backed tokens that for some of their internal logics, they need to understand what a given reference price is. So they reach out to an external web API via the Oracle, and they do that. So what this slide is really about is explaining that when we started, there was no Oracle piece in place. So we had to design everything. We had to understand how to secure the authenticity of data, how the communication was supposed to work, so the protocol, and what kind of data sources were interesting for the concept. And actually, when we started, there was no demand for oracles. That's the reality of things. So they were out there. There was a very nice wiki page on bitcoin.it explaining oracles, which I think is still there, but nobody really cared. Indeed, the traction started coming a couple of years later. Still, we kept building and securing it, and this is why today on the Ethereum mainnet we are the most widely used Oracle service, because we have been in production for so long. And we have also expanded to other blockchains. Of course, we love Ethereum, but we don't really know yet what people will value of decentralization. So we think decentralization is cool, but as you have seen in the previous slide, this is not what matters to the end user. This is what matters to us, to the technical people who are still in the space in the bearish phase of the market. But this is not what will make blockchain scale. So in the rest of the presentation, I will explain what, how the landscape is changing and how we are changing with it. So this is why the presentation is about Oracleize 2.0. The open challenges that you see are being addressed by several projects. So, for instance, the data source is an important piece. We keep discussing decentralization, but at the end of the day, the reliable data sources distributing data on the internet are very few. And when we ask for the temperature in Paris, everyone would just go on Google and trust Google, or get 2 or 3 data sources that probably at the end of the day are relying on the same source of data, the same sensors or the same things. So we are discussing about decentralizing something which would have little implications on the actual trust line that you have on the final payment triggering logic or anything like that. So the data sources is something that, for instance, Thomson Reuters has been addressing forever, right? Like the aggregate data, the distribute data, and the reason why I mentioned Thomson Reuters in this slide is that they are integrated with Ethereum and with some other projects. They are just signing their own data and sending it to the blockchain on demand. So if you trust Thomson Reuters, which is something 99% or 100% of the financial institutions do, then you can just get the data on the blockchain very easily, with no need to use complex logics or technologies to prove the authenticity of data. They are just signing their own data. There are other projects such as Streamer, which I think is in this room, and a few others that are trying to provide some registry mechanisms or some central data sources that can be considered reliable, offer some kind of guarantees, and basically give access to many other data sources or potentially interesting data. Other problems are indeed the authenticity of data. At the moment, the major approach being used is TEEs, so trusted execution environments or trusted computing techniques to make the deterministic, non-deterministic process in a way. So Intel SGX is one of the technologies being used. There are a few others that we have been using for years. It's just about isolating the data fetching process and proving to the blockchain that that isolation really happened and that the data is safe as long as you trust the isolation. That's it. And there are a few projects doing that. Town Crier from IC3, Cornell University has been working on that. We have been doing it with technologies of Qualcomm and Android, also building on the Ledger platform. Also Ledger, I think, is in this room. Hi, Nicholas. There are a few other approaches, like TLS Notary and Page Signer, which is the project we have been traditionally using, uses some kind of like software isolation in the sense that you need to trust like the Amazon isolation of Amazon Web Service for its claim to be useful. In general, the point here is that no isolation is perfect, and that if you were to trust in full those isolation techniques, you wouldn't be here discussing blockchain. You would just use those technologies in full. So it's a compromise, and our approach has been the one of using as many technologies as possible so that if one breaks, you don't compromise the security of your data on the blockchain. But yeah, there are many projects doing that. And something else is the underlying protocol. So that's the messy part. Because basically, we have been doing it. We have been designing the protocol to get data from the smart contracts, from the internet on smart contracts, because we had no choice. Like, there was no alternative. There was nothing available. Today, there are many projects trying to address that specific part. One is Chainlink. Another one is Witnet. I think also Rhombus is working on that part. And yeah, there is a lot of competition just to define the communication method to get data in, which is one of the open challenges in a way. And it's a growing ecosystem. Like, there are more and more players, and there is an increasing interest on solving once and for all the Oracle problem, which may already be solved or not. We don't know, because the demand is still limited, right? So we don't know how much decentralization people want, how much security contracts will require, and so on. Time will tell. So in our version 1.0, basically, we have built everything on those fronts so that we could provide a full service in production. So we tried approximately it was last year, so a few months ago, 1 year ago or something like that. We stopped for a minute saying, okay, fine. So what are we doing? So what we have, which you find on the right, and what does the community want? And I think we were quite satisfied in seeing that we had matched most of the community requests. Indeed, all of our work has been based on continuous iterations. Like, in the last year and a half, in the last 2 years, I think we have made something like 100 presentations. And in all presentations, we got some very useful feedback that at the end of the day resulted in some changes or in some minor interface improvements or things like that. So ease of use is very important. Like, now we are making everything more and more complicated, and this means the entry barrier is higher and higher. So we try to make it simple and to make some assumptions for the normal user so that you can make it safer if you want, but by default, the user interaction is really simple. We try to add no additional overhead in or constraints, right? So something else we did is the TE-based approach, multi-TE setup. I already discussed this. So basically, let's get it as safe as it can be today with the technologies we have available on the market. And basically, in order to build all those components, internally, we had to learn how to run things on mainnet, which is something that most of our competitors have not faced yet. And so we stopped for a second saying, okay, fine. So there are many projects trying to get out with some more decentralized approaches, some protocol changes or other things. But do they know what it means to run something on mainnet? Well, probably not as much as us at the moment. And something else that we have at the moment is basically, other than the expertise on mainnet, also the physical machines we had to build for ourselves for this multi-TE setup. So we got enterprises reaching out saying, fine, can I use this to get the multi-TE setup and blockchain? Then you go to a client, and the client, first question is, okay, can we get rid of the blockchain part? And basically, what we found out is that the multi-TE setup is actually interesting for many, and it can be useful on the blockchain, but is not necessarily applicable just there. Some open question marks are on the reduced cost, and which is a question from the community, and decentralization. Well, at the moment, most contracts on the Ethereum are have an administrator or someone that can change them, or rely on external data sources that are centralized. So the point is that we want to tend towards decentralization, but at the moment it's just for decentralization sake. Like, we don't know exactly how much decentralization will be needed, and we don't even know, which is the other open question mark, how much people will be ready to pay for that. Right now, we have, while speaking, with some of our friends at Chainlink, for instance, they were saying, fine, we offer a different range of cost, so the people will be able to choose how much decentralization they want. So in the worst case, they will get a centralized service, which is what Oracleize choose. But we expect people to want more decentralization. On our side, our clients, at the moment, which like on the mainnet, we have hundreds of contracts reaching out every month. They come to us saying, okay, fine, but 5 cents is too much for our request. Can you go below that? So actually, we are expecting people to want more decentralization. The reality of things is that projects are not willing to pay for decentralization today because there is no demand. Like, we are building many pieces, and we don't know what will be needed, what not. So these are big question marks, not just for us, but for the entire community. So this is very challenging for everyone, I think. So after those reasoning, we stop for a second saying, fine, you know what? Oracleize represents very well the Oracle use case. What we want to build going forward is not like just providing an Oracle. We want to do more. We are focusing on something different. So this is why today I'm announcing the rebranding from Oracleize to Provable. So Provable is like an adjective that will be used along with many services that we'll be releasing other than the Oracle service. And it represents better what our scope of work is and what we want to keep focusing on going forward. So the two technologies that we understand very well and that we want to keep working on are basically trusted computing, so trusted execution environments, and blockchain. We think they are complementary. Like, you need both to solve some of those problems. And Provable is something in between, the blockchain and the cybersecurity space, if you want. And we'll be using some of the technologies we have been building for the Oracle service, but also for different applications. So what we will keep providing is the existing interface, which is the interface of Oracleize 1.0. This is like a centralized interface, which is very cost effective. Like, the gas cost is minimal because you don't have the overhead of interacting with a more complex protocol. It will support decentralization. We've seen a bit how. And security oriented, battle tested. These are all things we have already discussed. So, and on the right, you find some numbers. So we have been live for 4 years on mainnet, just to understand the Oracle's opportunity. We are all competing on. This is like, at the moment, cumulative, this is 1 million transactions on mainnet. And keep in mind that those projects are complaining for paying 5 cents on each one of those queries. So it's a huge opportunity, right? Well, maybe one day. But today it's still limited. This is how we expect to tackle the decentralization problem with Oracleize 2.0, which will be the provable Oracle service. So the first one is keeping the existing Oracleize interface. It means that if you are not interested in the decentralization aspect, the interface stays the same. And basically, you get redundancy, potentially, from other people willing to run our infrastructure, which is something that we start to provide very soon. Something else is that we expect to integrate, like in the near future, with Chainlink, because Chainlink is like one project along with Witnet, which most likely will come next. And basically, they are focusing on the protocol and on solving the decentralization problem. This is like a very big challenge, and this is not what we want to focus on. So what we want to focus on is, the multi-T setup and the other parts of the service. So basically, you will be able to use Chainlink from, you will be able to use Oracleize on Chainlink directly using the same protocol. And in this case, it will be, provable node operator, basically. So it's like an enhanced experience on Chainlink, offering more guarantees than other nodes potentially. Something else that we've just started working on and we'll work on in the future, and we expect to integrate with, is the Ethereum Enterprise Alliance Trusted Computing API spec. So this is something on which projects such as EthCC and Intel have contributed a lot to. Our feedback is that it's really flexible and that we expect it to get adopted a lot by enterprises and on other blockchains potentially, or also on private chains. So this is something that Oracleize will tackle as well. Cost effectiveness, I will not say much because it's not the focus, but just to say that our existing Oracleize 1.0 interface is continuously getting new features and reducing the gas cost. So basically, since the layer is very thin, we are getting it down as much as possible. Keep in mind that every time you have additional complexity interacting with the protocol, you are making the entire blockchain more complex to scale, because you are basically propagating the gas cost to all projects needing an Oracle. So this is a nightmare. So that's why we are trying to move it down as much as possible. Something else we are making a new product is something that we had built for the Oracle. It's still called the random data source within Oracleize. And it can be used outside of the blockchain context. It's basically a provable random number generator. It doesn't need the blockchain again because it's built within the trusted execution environments. We are providing it with ledger TEs. We are getting certified the Intel SGX version. What is the certification? Well, it means that basically it's an authorized code audit, so that authorized casinos, for instance, can use it with their own license. So this is very important to move forward also this gambling movement, or this safer gambling opportunity out there. It's available on the blockchain, and basically the idea again is to prove everything from the inception, so code design, from the code base itself, the security of the code, to the execution, so that the random number you get, is being generated by the correct piece of code and not by something else. What casinos has been traditionally doing outside of the blockchain space is certifying the code and then potentially running something else. You have no idea what's running in production. So that's pointless, of course. We know that. On blockchain, we have been focusing more probably on the second part. We are trying to focus on both. Something else is like, if you want an HSM 2.0, it's like the physical machines we have been using to run Oracleize. And this is like a provable security module. This is a multi-T setup that can be useful to, for example, secure sidechains, proof of authority networks, to provide, I don't know, EOS block producer with additional guarantees, many things. I mean, we don't care much. You can also use it, to run your own Chainlink node or something else. You can run whatever you like. This is just the hardware that you may decide to use, and we provide some open source simple interfaces to leverage it, so that you can use it wherever you like. Either to provide additional redundancy to Oracleize, or to a different network, or on another blockchain, or just for your own enterprise needs. So just to recap, we are rebranding. So Oracleize going forward will be called Provable Oracle Service. And we will be integrating shortly with Chainlink and later on with other projects. So we are very open to interoperate with other people in the space, so that everyone can focus on the part that they are most interested in. And the provable random number generator, a new version of it, and the use of it outside of the blockchain will be released very soon. And the provable security module is already available, so if you're interested, just reach out to me. Thank you for your attention, and if there is any question, I think I may have some time to pick one or two. Thank you.
So one of the issues with trusted random number generation on a blockchain is the possibility for the provider to exit if it gives an advantage to them, to simply not provide the randomness. What on-chain guarantees are you providing to ensure that you'll be generating the requisite randomness?
Yeah, that's a very good question. So basically, what you really want to prevent is the operator running the random number generator being able to collude, or you will go back to the miners problem, where miners on chain could have colluded. So the way you do that is by asking to the enclave running the random number generator, so to the code, to the off-chain code, to basically commit to some data that it couldn't like know in advance, and that is tied to the player. So typically, what this means in practice, and this is something we have been running for 1 year, and we have released a white paper on it a while ago, is basically generating on-chain unknowns, which is chosen on the blockchain and is strictly dependent on the player and on the context of the blockchain. Like, for example, you can make it dependent on the block hash as well. But this is just a nonce that is used for assigning the task of the random number generator beforehand. Then what happens is that the enclave needs to prove that the random number generator has been running with that commitment in place. And when you get the data back, basically the on-chain Solidity code will verify the attestation, which is dependent on the isolation technique you have used. And it will see that the commitment is matching, and that there was no reply attack possible, and that the operator couldn't know in advance all these different components or tamper with the number generation, random number generation. Something else you can do is basically put a time constraint in place, which makes it more and more secure. We have done an analysis on that in the white paper. If you're interested, I can share that.
But Provable will be in control of the enclave, right?
Provable is just executing it, but is not in control of the other pieces. So basically, the code is fully open source, and you can verify what the code does. It's being executed in a trusted execution environment, which is not under our control, and the external attestation is proving that everything has run as expected. So as long as you trust like in the case of SGX, if you trust Intel, you can verify that the operator, us or you with the security module, has not tampered with the normal expected execution.
But so if Provable decides to abort the execution, then the operation of the contract stops. Is that correct?
That's why you can potentially use it by yourself, or just execute the same enclave on your own code, or use a decentralized network and ask two different operators to do the same.
Okay, thanks.
Hello. When you talk about your own HSM, usually they are built by well-known companies like Overture or so on. Did you get some partnership to have it certified?
I'm not sure I got the question in full, but the idea of the HSM is that basically you will be able to get the HSM on premises and to use it yourself.
My question is about who do you made it with? Did you make some partnership with some well-known companies which are usually providing services for certification?
This is not the case yet. What we are doing at the moment is using different TEs so that you can verify independently via the proofs the HSM distributes that those TEs has been used, and that according to Intel, according to Qualcomm, to Google, and so on, and to Ledger, for instance, all these TEs has been using as expected, and that the execution has run through their systems.
Ciao, Thomas. Yeah, I wanted to ask in general, you're probably the only company that made tooling for blockchain developers that is actually profitable right now. How do you see, in general, the ecosystem and new companies getting in the space of tooling and being sustainable in the long term?
That's a very good question. Actually, I think the challenging part is on building the protocol, right? That's why companies building protocols have been either doing ICOs and trying to make a business model on the protocol, or they have been looking for research grants, which are it's very unlikely that a VC will give you funds for building an open source protocol where most of the protocols in the last decades have made little to no money. So in our case, the value added is on the fact that we have built the protocol for our own needs, but we have also been the operator running the Oracle service. And the main challenge is in proving that we have been doing it well while keeping all the opportunity for the market on our side. Because right now, as I showed, the cost people are willing to pay is very low and is mostly based on volumes. So going forward, if we expect thousands of people to be providing node redundancies, I think they will not be happy to do that for a fraction for 1,000th of the monies we have made, because this is very little. So of course, at the moment, if the traction doesn't grow, I think most projects in this space will eventually die. So we need to understand which are the big questions right now, in my opinion. What is the cost of decentralization, indeed, and how much decentralization people want, and for what applications? Because we are just assuming people care about decentralization. The reality is that we have built a decentralized ecosystem. At the moment, the traction is very little, other than attendance at conferences from technical people in the space.
Thanks.
Hi, so you talked before about having certification for gambling. Is that something you're looking at more generally for, say, sort of PCI, SARS-OX type stuff?
You're asking about the certification of the RNG?
Yeah, are you going to try and do that more generally for things like, SARS-Oxley compliance, that sort of thing?
At the moment, the certifications we got are limited to the random number generator for the scope of casinos that are running in a regulated way, which is not the case for most blockchain ones. But basically, we have used certificators that are recognized by most gambling jurisdictions. So this is something they are familiar with, and something that will be automatically be recognizable and usable by those companies.
Okay.
Thank you again. Thanks.